Hi everyone, and welcome to Programming 2 lab number 3. We get started right away. We're going to look at this week object encapsulation and protecting object data using get and set methods. So I'll get started right away. I've already created my, my Java project. I'm going to add a new class. The name of the class is going to be bank account. And this is going to be modeling a bank account, really. And what do we usually find in bank accounts? It's usually just the customer name and how much money they have in the account, or the account's balance. Now, this is rather sensitive information, and we can see in a number of ways that we might want to limit the, say, access of these instance variables. So right now, whenever we create, let's say, a bank account, a bank application, let's say, so we're going to use bank accounts in our programs, then we might have something like this. We might have bank account and account is equal to new bank account. We'd like to give it something like the username, or the customer name. Of course, we haven't created that constructor yet, so let's just go ahead and do that. You can even do it quickly by typing that in and just go ahead and creating it here. Customer name, like that. Whoops. And unfortunately, Eclipse puts it in a really poor way. I don't like this because the instance variables are now at the bottom, so I don't recommend that you do that. This is the correct way, customer name. And what we're going to do is we're going to set this dot customer name is equal to customer name. And the balance of a new bank account should be set to, let's say, 0. Now you'll notice I can type something like this, balance is equal to 0, because I'm not including a instance variable like so. Now, if I had done that, then this balance refers to this balance here. So in order to actually instantiate or to access this instance variable, I need this keyword, this dot balance. When I remove this, then what happens is that Java first looks for the variable balance within the scope of this constructor method. And by scope, I mean between these two brackets, what's highlighted here. If it can't find a locally declared variable or an instance parameter with that name, its next check is up here in the instance variables, which is exactly where this balance is located. But what I always recommend is to make this absolutely clear and refer to it as this dot, because most certainly this dot balance refers to the balance instance variable here. So this is all matters of scoping in Java. And we can go ahead and save this. Now you'll notice I created a bank account constructor that just changed the customer name based on the input. And of course, given any account, we can just get the customer name. We can just do a system.out, a print line, customer name. We can run that. And of course, we can also get the balance as well. Now there's a slight problem with this. What we should really be doing is creating some methods that control the access to these instance variables. So here we have customer name, which is fine, and you might later alter it, perhaps, you might not. But the balance is a little bit more problematic. So we could always just say an account dot balance is maybe add $1,000 to my balance, or $100,000 without any sort of checks or whatever. That would be nice if we could just go ahead and add all sorts of digits to our online bank account balance. Unfortunately, it doesn't work that way. So what we need to do is we actually need to restrict access to these instance variables. And we do so as follows. We do so as using an access modifier. So right now these are accessible by default in the current package, which is lab3. So any class that I store in this package here, lab3, can access these variables. Even worse, if I made them public, then that means any class, any Java class anywhere, let's say even in lab 1, lab 2, could access these and change them. We don't want that. We want to make them private, in fact, and that means that we're unable to even look at them. We can't see them and we can't change them. So you'll notice that an error occurred here. I now cannot see this anymore. I can't change it. It says the field bankaccount.customer name is not visible. So how do I gain access to this customer name? Well, it's quite easy. What I do is I create a get and set method. So let's say that I want to give access to the customer name. So now what I've done is I've created a method that will get the customer's name and return it as a string, like so. So instead of this, I have to write get customer name, and I'm able to do that. Whoops. Yes, that's right. Forgot to save it. Like that. So when I run that, I can now see the customer's name. I can print it out. So if I wanted to then change the customer name, I can't just simply say an account.name is equal to another name. In fact, I have to create a setter. I have to be able to set the customer name. And we have to set it to a particular input value, so we'll call it customer name. Like so. Whoops, some spelling mistakes. There we go. So I've created a getter and a setter. So how do I change the name? Well, I set customer name, another name. So when I run this now, I have Robin Bank and then another name. So I've changed the name of the customer. Now we could do the same for the balance as well. Let's say we want to write get and set methods for the balance. Public int get balance, and just return this dot balance, and public void set balance int balance. This dot balance is equal to balance. So I can set the value of the balance as well. But we run into a bit of difficulty because, as I mentioned before, we haven't really gained too much. In the sense that we can now set the balance to whatever we want. And as I mentioned before, that's not really how banks work. So I can actually just set the balance of a bank account to be thousands of dollars when really I don't have that money to spend. So what do we do? Let's just do a system out here. Like so. You can see the before and after. You can remove those for now. We run that. So I've first, when I open the account, I have $0, and now I have $10,000 in the account. It's not very fair. So what I would recommend then is that we don't actually need to change all object attributes. Just because I have these object attributes here doesn't mean that I should give people access to them. They may be able to see them, but maybe not change them. So what I would propose is maybe getting rid of the set balance. Having get balance is fine. You should be able to see the account balance. But banks usually have the following functionality. Public void or int withdraw int amount. So this maybe returns, it needn't return anything actually, it can just be void, but what it does is it takes an amount of money off of the balance. You imagine when you go to a cash point and you withdraw some money, and what happens is the amount that you withdraw is taken off of your account, and in turn you get the physical amount of money that you've asked for. But in a computer science sense, we needn't really return a particular value. We can just ask the account to simulate the amount that's withdrawn. And how do we do that? Well, we simply just say this dot balance, and we take off some amount like that. But of course we have to make sure that the amount does not exceed the balance that's currently stored. You can't take out more money than you have in the account. So we can place a guard there. We can say if amount is less than or equal to the balance in the bank account, then subtract the amount. Otherwise, we're not doing anything. You don't get to do it. And you might want to return a value that says whether or not the withdrawal was successful or whatnot, but for now, I'm just simply withdrawing the money and not returning any output. So let's see how that goes. Of course, we've gotten rid of set balance. We're going to look at withdraw. Well, of course, we can't really withdraw too much without depositing it first, so we better create a method, public void deposit int amount. So all we need to do is just make sure that perhaps the amount that we're trying to deposit is a positive value. If amount greater than 0, then this dot balance plus equal amount. So we add the amount to the balance, and we don't return anything. Otherwise, it doesn't do anything. Similarly here. So let's see how these two methods work. So the first thing I'm going to do is I'm going to deposit $5, and we can see the amount there. And then we're going to see the change in that. Pretty straightforward. So here's the output of that. If I run that, first it gets the balance initially, which is 0. I deposit $5, and then I print out the balance again, and it's 5. What about if I try to now withdraw $2? Then the amount should be, whoops, well, you can deposit even more, but let's just say we want to withdraw $2. Then, of course, the amount is decremented to 3. And finally, what happens if I just decide to withdraw a large amount of money that I don't actually have? What should be the change in the balance of my bank account? Well, first of 0, I deposited $5. I took out $2, and then I tried to take out $100, but I don't have enough funds, so it doesn't change the bank account balance. This gives you an idea of the notion of data encapsulation, which in our objects, in which we have get and set methods that control the values that we set our data to. So we can look again at the customer name example here, set customer name. Now it would be very bad if someone decided to change their customer name to the null object reference, which is perfectly reasonable. Like someone could actually do that. They could say up here we can set the customer name just simply to null, and then we can print out the customer name here. So you'll notice that it's null. This is not a very good idea. We would not like an object a null object reference. We want just it to be changed to another type of name, or have some sort of check to make sure that it is indeed a string that we're changing this to and not a null reference. So we could check for that. If customer name not equal to null, then change the name. Like that. So make sure that you're not setting it to null. Of course, if I try to run this again with null, it won't actually change it at all. It'll just keep it a problem bank. So there's many ways of controlling the way that your data changes within an object. And sometimes you might not even want a set method or a get method for some of your bank account details, maybe or any other sort of class or object details, because it's sensitive information and it's not important to the external user of your account or of your objects. You'll notice here that I'm using an account. I'm using it in terms of the functionality that's provided to me, in terms of the methods that are provided to me. That's the only way I can use an account object's data, is if you let me get the customer name or let me set the customer name, and you can decide the actual way that the object data changes. So that's all for this week. I'll see you in the lab, and good luck on the assignment, which I'm sure that this YouTube video will help you get prepared for. Thank you very much.